To my channel, and today we will continue the crowd computing wisdom of crowds. This is part 2 of the video where we will discuss how to code the counting of the jelly beans in the jar problem. Okay, so let's get started. I will reiterate in short what we are going to do. We will have an array of all the estimates or the guesses that people made how many candies could be in the jar. We will sort all the guesses in ascending order using sort function. Then we will calculate. Okay, I have to tell you about the 10% mean, what it means, that we will look when we start to code. Okay, we will calculate what should be the value of a 10% mean. Okay, and then what we will do is we will use array slicing, list slicing, to keep a subset of the guesses only. Okay, that you will understand when we start to code. Okay, and then we will calculate now the mean of all of the subset of all the guesses by the people, and we will plot the value of actual answers of what is the actual number of jelly beans in the jar, actual value, and compare it with median and mean, 10% trimmed mean, and we will see which value is nearer, giving more accurate value. Okay, so let's get started. So first what we will do is we will import libraries that would be required. So we will write from statistics, import mean. Then what we will do is we will create the estimates array. Already have in my notepad the values for the array, the yeah, the what the people guessed, the actual the number of jelly beans, what could be the number of jelly beans in the jar. We will check. Yes, it's closed. Now what we will do, we will use list dot sort function. Okay, estimates dot sort function, and we will print um, the estimates. Okay, as the sort list dot sort function, what it does is, in the original array only it will sort all the values in ascending. By default it will do in ascending order. Let us print the estimates, and let us run this to see what we get. We are getting in the sorted order or not. Yes, 15, 60, 70, 80, 90, 100. Yes. And what is the maximum value? Let us check. Okay, fine. Okay, fine. Okay. Let us, in this list, at the end, let us add very large guess also. We will add 115 as well, as a guess, 115. So how we can do it is estimates, that is list dot append function, append. What it will do is it will add to the end of the list. We will add a guess of maybe 1450. Okay, and now let us print estimates. Okay, okay, the second one, let us see it got added at the end or not. 1450. Yes. All right, let us remove these print statements. Okay, okay, okay. Now what we will do is we will calculate how many, what is the value of 10% trimmed mean. What does 10% trimmed mean means? You know that in for finding mean, what do we do? For finding mean, we add all the estimates, right? We will add it. So on adding, what happens is when you add a very small numbers like 1 plus 3 plus 4 plus 1000, the answer of this sum, what it comes, it is very near to 1000, right? It will be 1000 uh, plus 4 plus 3 7 8, right? So 1008, right? And yeah, this sum is nearer to the high value if all the data points or all the estimates or guesses are very small numbers. Mostly they are small numbers, and only one person made a huge guess of 1000, 2000, 3000. The mean value comes nearer to that outlier, the bigger values. It will come to the bigger value, and mean is giving you the middle value, on an average or middle value of all the data points. But if you look carefully, the remaining most of the data points or most of the guesses made by the people in the jar are very less. So the middle value should be lesser. Only one person made a huge guess. So why but the mean, the problem is the answer would be more towards the bigger value, bigger guesses. Okay, 1 2 3 4. So it is telling you uh, 4 to the 8, 4 5 is 20, 4 to the 8. So middle value is 252, which is very very large than the majority of the guesses. Majority of the guesses are very small number, but this middle value, middle, on an average what people guessed, this number is coming out to be very high due to this huge value, impact of this huge value. So what we are trying to do is, by 10% trimmed mean, we will remove the very low guesses, 10% of the very low guesses, and we will remove the 10% of the very high guesses, extreme guesses. So what will happen is, you will have 10% of your guesses which are very low. 10% of low guesses, we will remove this, remove, and 10% of very high guesses, 10% of very high guesses, extremely high guesses, we will also remove those from our list and then calculate the mean, then calculate the middle value, the middle value. Okay, all right. Yes. Okay. So I hope you have understood what 10% trimmed mean means. Now for the length of array, we are the total guesses. Out of total guesses, what is the value of 10%? That is called TV. Trimmed value means how many 10% of this length of the list, how many we have to remove from the lowest values and the highest values. Okay. So we will, what we will do is, we will calculate 10%, that is zero point 0.1 into the length of our estimates. Estimates mean the guesses that people make, and uh, this number will be a floating. This PV will come out to be a decimal number or float. So we have to convert it into an integer. Okay, because we cannot remove a decimal number of elements from a list. We can remove only integer number of things from a list. Okay, then we will use list slicing. Okay, list slicing means, okay, let us see what list slicing means. So list slicing means, imagine you have a big set of something, a big set. Okay, and the index is starting from 0, 1, 2, 3, 4, 5. Okay, these are your indexes. There are 6 elements in your list. Okay, but you don't want the entire list. Okay, what you want is a small portion of this whole list. You want only the elements from the second index to the fourth index. So how can you do that? It's like this. You have a huge bread loaf and you don't want to eat the whole bread loaf at once, and all the what you do, you want only 3 slices of the loaf, so or a subset of the loaf. Okay, so what you do, you tell the shop person that you want the loaf number, the slice number 2 to 4. You don't want the whole bread loaf, so it is similar to that. Okay, so what is the syntax of list slicing? The name of the list, okay, list name, and then you have to give the start index from which index you want to keep in your subset, and end index plus 1. End index plus 1 means I want the element starting from 2. I want the number or the value which is present at second location to last should be fourth location, so I will add 1 to it. So I will write 2 to 5. Why 5? Cause then it will give you the value answer from 2 to 4. The last index is excluded. Okay, I hope you understood. Now let us code. Okay, estimates is equal to estimates, and list slicing gives you back a new array, a new list. So you have to create a variable to store that list. In the original estimates, the changes will not be done. Okay, the original list will not be changed. It will return a new list which you have to store in a new variable. Okay, so we are starting, we want it from TV. TV means you are removing the lower 10% of the elements. Okay, you are starting from 10% values plus 1. Okay, that is TV. Okay, because it the index is starting from 0. Okay, and then len of the length of the whole array estimates minus TV. Okay, I will explain why this is working. Okay. Okay, we will take an example. Okay, this is our estimates array. For example, we will take 10 values. Okay, we have 10 elements in our estimates array. 0, some value is there, 1 maybe, 1, 20 maybe, 2, 7, 9, 15, 25 maybe, 5, okay, then 96, 7, oh, okay, 7, 7, okay, let us take 70, 29, 8, 1000, okay. From 0 to 9, you have 10. So the length of your guesses or estimate is equal to, this is your guesses array. Guess array. Okay. Guess list. Okay. And the length of this list is 10. Okay. And I know what is the 10% value, TV value of 10? 1. So you will remove, you want to remove the 0th index 1 value, right? And you want to remove the 9th value, right? In ascending order, 1 will come at 0th index and 1000 will come at this is the maximum value, 9th index. So you will remove 0th index and 9th index. So where you are starting, you are starting at index 1. and 1 is equal to the value of TV, right? So how do you write? Guess is equal to guess. Your start index is the TV value, right? TV. And what should be your end index plus 1? You have to put end index plus 1, right? And what we put? We put the length of the guesses array, that is 10. है ना? Length of the guesses array is 10 minus TV. So that comes out to be minus 1. है ना? And this length of the array we can write as last index plus 1, end index plus 1. I'm erasing this part. Length of an array can be written as the end index of the array plus 1, right? Because your last index is 9 of any array. So what we will do is, so your length of guesses is nothing but the end index of the array plus 1 minus TV value, right? So end index minus TV, right? And you are adding plus 1. That means it is actually last index you want plus 1. Okay. I hope you understood. If not, pause at the video and think about it. That's why we are writing it length of your array guess, है ना, minus TV, that is your last index, that is 10 minus 1, that is 9. So your slice will end at 8. So this value will be nothing but guess starting index 1, ending index 9. And we know that list in list slicing, the end index you have till where you want to keep in your subset, one larger you have to put, right? So we have put 9, so the subset will keep only from 1 to 8. Okay, I hope you have understood. Now next we will move on to print the mean of estimates. Okay, so this mean value 10%. This is the 10% mean value, because wait, I will remove this, because before this step we have already removed from the subset, we have already removed the 10% highest and lowest values. So the mean we have calculated now is the 10% mean value, and this is our answer, our prediction of what should be the number of jelly beans in the jar. Let us execute and see this. 386, and actually uh, in the answer the jelly beans number is 375, which is very very near. Okay, 386 is very good estimate, okay, of how many jelly beans are there in the jar. Okay, so yeah, in the next video we will plot the 10% mean values, the actual answer and the median value, and see which one is a good approximate answer and nearest to the actual answer of the number of jelly beans in the jar. Okay, bye bye, take care and happy coding.